Okay, well, good morning, class, or good afternoon. So it's good to see you today. I gotta make sure I'm fixed here. So, got that monitor in the back, which always helps me. I put that on my tie so it doesn't get pulled way over here. But when I go left on the monitor, it goes right. So, anyway, I'm a little challenged in that with spatial relationships. I hope you're having a good day today. We got the exam behind us. Hope it was an okay experience. I rarely have a student email me after an exam and say, "Wee, that was so much fun." So, but maybe it was. Maybe it was for you a show-off opportunity. I hope it was. So. I think you kind of see probably how things are going to roll for the next two exams. And by the way, if anyone feels you really stubbed your toe on the first exam, I'm going to give that comprehensive makeup exam the last week of class, right before final exam. And I'm not reading the syllabus read the detail on that. I'll probably open that up. Open it up to anyone who wants to take it. So I kind of have a baseline on the syllabus about how much reward you can get from that, but I could modify that in your favor if necessary. But you might look at that if you felt you did poorly on the exam and you want another shot at it. So I hope you saw that at least the harder problems on the test were reflective of that problem set, those two problem sets that I put out for you guys. So I'll probably do that for the next two exams as well. So there's 3 exams in the course, and so at the end of the 6th week, I typically give an exam. So we're starting the 7th week here, and then at the end of the 11th and then the 16th week, we'll have exams. So that last one we'll call it your final exam, but it'll just be another unit exam. So let me know if you have questions. I need to throw a couple switches on that exam still for you to be able to go back in and look at your work and all that, see what your answers were. So I hope to do that before I lay my head on my pillow tonight. So if you got any questions, be sure to reach out to me. Okay, so we are going to start today chapter 7, because chapter 6 that we've already done last week is part of unit 2. So kind of did that intentionally to give a little space between unit 1 and the unit 1 exam. We went ahead and proceeded into unit 2 with chapter 6. So today we'll go to chapter 7. My intent, I think, I've looked at this, I believe we'll be skipping chapter 8. I'll have more to say about that now, and we'll go to chapter 9. So at any rate, so today we'll talk about utility. Chapter 7 deals with utility. And so we're going to look at the demand side of the economy, if you will. We'll look at consumer behavior and what consumers and demanders are looking for when they participate in the marketplace. Utility is the big word, okay? Utility is just a fancy name for satisfaction. And so if you go buy a bag of apples at the store or what have you, you're looking for satisfaction. You're looking for something to fill your tummy or what have you. We look for satisfaction in a variety of ways. I guess I'm thinking of a joke that has to deal with utility. I don't know if it'd be appreciated here or not, but there's economists use that word a lot to refer to the satisfaction they derive in life. So we could use the term satisfaction if we wanted to. Thing about utility is a couple things. Is we derive satisfaction, if you will, or utility from consuming a good. And we may be in a situation where over a finite period of time, we're consuming consecutive units of a good. Okay, so I use the pancake example a lot. Okay, so when I go out with my family or my wife on Saturday morning, we like to go out and eat breakfast. I get those pancakes, put some syrup on there. I probably put too much on there, but that first pancake's really good, right? As we all know, though, the second one's not as good as the first, and the third one's not as good as the second. And you reach a satiation point where you're completely satisfied. You don't want any more pancakes, right? And so it may be the 7th or 8th pancake, however large they are, where you say, hey, stop. My total utility is not increasing anymore. My total satisfaction is not increasing with additional units. And then beyond that point, if you're force-fed pancakes, okay, then your total utility would go down. Okay? What you see is that utility can increase to a maximum, then it can decrease. And ideally, what you would do as you're consuming pancakes is one thing you're striving for, and we're going to put something with this in a minute, but you're looking to maximize your utility from your budget. Okay? And so there's a little bit more to it than that, as we're going to see in a minute. You have to look at the price of the good that you're consuming and so forth. But what we do see that's universal is that marginal utility, the utility derived from each successive pancake or unit of the good, decreases over time, in a period of time, okay? Whatever the period of time is. Now, if you gave me 20 pancakes, I'll eat them all if you give me enough time, okay? So it's important that we have a time reference here. So within a week or within one meal or what have you. And so you always got to couch it that way. But beginning with the first unit typically, and then the second one, there's a few exceptions to this, but generally speaking, the second unit you consume of a particular good in a finite period of time will deliver less satisfaction than did the first, and then so forth. So this is called the law of diminishing marginal utility. So I would like to delve into chapter 7 here by going to the PowerPoint here, and we will look at chapter 7 topics. I hope seems like my monitors may be reversed, but we're about to find out. Okay, good. All right, awesome. Okay, so these are the topics we're going to talk about here today in chapter 7, the law of diminishing marginal utility. So total utility can continue to increase. 4 pancakes very well may give more satisfaction than 3. So you got to distinguish between total and marginal utility. 4 pancakes may be better than 3, but the 4th one delivers less satisfaction than does the 3rd one. Okay, so there's a difference between total utility and quantifying that and marginal utility and quantifying that. Okay, so we're going to look at that. This is a very ubiquitous law in nature, diminishing marginal utility. Then that'll lead us to the theory of consumer behavior. How do consumers make choices between different consumption bundles? Then we'll look at what's called the utility maximization rule, or the rational spending rule is another term we could use, and the demand curve. So we're going to go back and we're going to drive that demand curve again that we've been working with. We've talked about the law of demand, how prices and quantity demanded move in opposite directions. So we're going to give a little more justification for the law of demand and how that then determines that the demand curve slopes downward. Embedded in that are substitution and income effects, okay, for consumers. And then we'll look at some applications and so forth. So diminishing marginal utility. There's a law here, okay, that you're just going to have to accept here, and hopefully it makes sense. Hopefully this is intuitive. But as consumption of a good or service increases, the marginal utility obtained from each additional unit of the good or service decreases. Okay? So this explains why there's a downward sloping demand curve. We mentioned this back there when we introduced the demand curve. Demand curve's downward sloping in P versus Q space. You have price on the vertical axis. It's downward sloping because of diminishing marginal utility. Since you derive less satisfaction from the second pancake than you do from the first, you would pay less for the second than you would for the first if you had to buy your pancakes one at a time. Okay? So, there's got to be a tight correlation there. From the satisfaction you derive from successive units and the price, the maximum price you're willing and able to pay, which is what a demand curve represents. So, diminishing marginal utility explains why the demand curve slopes downward. Now, you know, at first blush you'd say, well, yeah, but there's a little depth to this that we'll explore here in a minute. It's not. Sometimes we take things for granted that aren't really granted, okay? And this is one of those we'll see in a minute. Actually, theoretically, it is possible for a demand curve to slope upward. You say, what? Or would kind of violate the law of diminishing marginal utility, or would appear to, okay? There's a class we might look at Giffen goods and so forth, but in particular, there's Veblen goods, named for Thorsten Veblen. I believe I've got his first name right, but at any rate, he talked how some people will buy more of a particular good when the price goes up. Okay, the quantity they purchase would increase with the price, and you say, well, why would anyone do that? Anybody got an idea on that? You might if it's got snob appeal, right? Not that no one here's a snob, see, so it's far from our thinking. But the idea is to impress somebody else. You might buy a fancy, you know, a very expensive watch or something like that. So, I mean, there are instances where price and quantity demanded move together. But we're going to kind of set those things aside here and talk about, you know, kind of what's true in general is that the downward sloping demand curve is reflective of this law that we're looking at, the law of diminishing marginal utility. So utility is the satisfaction one gets from consuming a good or service. It's not the same thing as usefulness. Okay, your book makes a big deal out of this on page 136 and so forth. I mean, heck, the Mona Lisa is not that useful, I suppose. I guess if you had if you needed some kindling for your fireplace, probably the Mona Lisa would serve that purpose. But I'm being a little facetious there. As far as usefulness goes, it's not synonymous with, that term's not synonymous with satisfaction. You can derive satisfaction from things that really don't directly meet your physical needs. So it's not the same as usefulness. Utility is subjective too, okay? With respect to the Mona Lisa again, okay? Or whatever it might be, two different people can look at the same thing or consider the same good and have different appraisals about the satisfaction they derive from it. So, you know, I don't know. I never was into the arts as much as I probably should have been and so forth. But you know, when I took my art history class as an undergraduate, I was surrounded by classmates who were enraptured by some of the artwork that we would consider in that class. To me, it was, I thought, well, I don't know. I don't get a whole lot out of that. Or Bill Russell back then took a basketball and dipped it in some paint and dribbled it on a canvas. And wow, it was a work of art. So at any rate, you know, the point here is utility is subjective. Now that's a kind of a disturbing thing for us today in our study of economics, because it means you really can't quantify it. You can't really. We will attach a satisfaction unit to consumption levels of any good. We'll talk about utils here in a minute, but really utility itself we say is ordinal, but it's not something. In other words, we can order consumption bundles. We can say I could prefer this one over here to this one. Okay, I can order things, but I can't say I derive twice as much satisfaction from this unit of good A that I do from this unit of good B. Does that make sense? So a pound of apples, I may say, gives me twice as many utility points. We'll call them here in a minute, utils. But really, all I can say very precisely is that I can order my consumption, but I can't really quantify the satisfaction I derive from those. So it's difficult, at least it's difficult to quantify, as you see here at the bottom. So we're going to make the attempt, though, because we need to look at some theory that's going to address consumer behavior. So first off, a util is one unit of satisfaction or pleasure. Okay, so you eat an apple, and imagine having a little meter hooked to your body and the needle moves a little bit, okay? And so it moves however many utils will tell you the satisfaction you derive from that. So I don't know if a wee is a util or whoopee is 2 utils or what, but it's a unit of satisfaction, okay? So total utility is the total amount of satisfaction you derive from consuming whatever. Marginal utility is the extra satisfaction from an additional unit of the good. So we've used the term marginal before, and we said, you know, marginal means an additional unit or what have you. We talked about the margin around the print in your book and so forth. That's the extra amount of paper that's around your print, just to kind of give you a margin. I remember driving with my family from Durango to Silverton, Colorado on that little road that hugs the edge of the mountain. You look over there and it's a couple thousand feet straight down perhaps, I don't know. You know, I remember remarking once to the family, said, boy, we don't have much margin here, okay? And that didn't sit well with my wife. I think she didn't want to look in that direction. And I understand that completely, because if you don't have much margin, there's not much safety there. It means there's not much road, there's not much territory there for you to pull a car over. So I'm being a little silly here this morning, but it's the extra satisfaction from an additional unit of the good. So we'll have a way of calculating marginal utility. Marginal utility is the change in total utility divided by the change in quantity. So for instance, you know, if you've been consuming 10 ice cream cones every week for the past several years, 10 ice cream cones every week, and you say, well, this week I've been a good boy or something, I'm going to have 12 ice cream cones. So if you're going to eat 12 ice cream cones, we might ask ourselves, what's the marginal utility associated with the 11th and the 12th ice cream cone? So you'd look at the change in total utility and divide it by 2 ice cream cones. So in that case, suppose your increase in total utility, your increase is 40 utils. So you take 40, that would be the change in total utility, the numerator, and divide by the change in quantity. 2 cones, that would be 20 utils per cone, 40 divided by 2. That would be the marginal utility we'd assume would be associated with the 11th and the 12th cone. Now actually, that would be an average marginal utility, because we know what? The marginal utility of the 11th exceeds the 12th. So it could be the 11th supplies 21 utils and the 12th supplies 19, okay? But you see how we kind of determine the marginal utility for the 11th and the 12th. If that's the increment in our consumption over a particular period of time, you would just take that increment and divide it into the change in total utility. So here's the idea here in a graph. You've got this graph in your text. This is very important here, where we have tacos. Okay, I like tacos. Maybe you like tacos too. And you'll see tacos consumed per meal. So again, you always have a finite period of time. Okay, if you don't say per meal or per day or something like that, well, heck, give me 700 tacos, I'll eat them. Okay, I'll eat 2 a day for a year. I'll be happy to do that. You know, if that's all I got. So the point here is that you have to have a period of time. Tacos consumed in one setting or one meal. Here's a total utility here. I want you to see that the total utility, first off, there in the second column, goes up, and then it hits a maximum and it goes down. That's reflective of the parabola you see there on the right. So you'll notice this is what I was talking about a while ago. There's a certain level of consuming tacos that's going to give you the most satisfaction. Beyond that, your stomach starts to hurt, okay? And it could be, if you continue to do that, then total utility may go to 0. If you eat so much, they got to haul you to the hospital and pump your stomach or something like that. You kill yourself eating tacos, then you would have been better off to have never eaten the first taco. I mean, that can happen, okay? So this parabola you see here has a maximum. So it goes up and it goes down. Like throwing a ball up in the air, it's going to go up and go down. In fact, I'll use that analogy here a little more in a minute. You'll see also in the last column there, though, the marginal utility goes down. So marginal utility, again using this formula here. Now here it's real easy, that last block there, marginal utility is change in total utility over change in quantity. The change in quantity here is real easy, okay, from one unit to the next. So from one taco, from the 0th taco to the first, you're only incrementing by one. So delta Q going from one line of this table to the next, whoops, is always 1 in that expression. So it's a change in total utility over 1. So the marginal utility is the difference in these two numbers here divided by the first. But let me throw this out here just a second, okay? What if I go to this table here, we take out all the odd numbers of tacos. So take out the 1, the 3, the 5. And so if all the data you had given here were 0, 2, 4, 6, and I say, what's the marginal utility associated with the first taco? Well, then this formula we were just looking at really becomes important to us. You take the change in total utility. So remember, you don't have an odd, we don't have that data here. So we go from 0 to 18 for 2 tacos. And so the change in total utility is 18 and change in quantity is 2. So you'd say 9, okay? Well, guess what? I mean, actually, the marginal utility of the first taco is 10, not 9, but it's 8 for the second taco. So do you see that what we calculated really by using this formula here at the bottom is the average marginal utility over the range of width delta Q, okay? So it's a way of getting as close as we can from the data that's given. So if we only had the even consumption numbers given there, then we get something close to the marginal utility. Of course, the average of 10 and 8 is indeed 9 here. And so that's why that formula is so useful. Typically, you don't have, especially with a large consumption universe here, you don't have utility given at every incremental level, okay, for each unit increment. These could be in units of 10, 1,000, what have you. When we start talking about the demand side of a macroeconomy or something like that, you know, we're going to have to put some zeros behind these numbers. And when we do, at least do that. And when we do, then using this formula at the bottom becomes imperative. All right, okay, but the other thing I want us to see here is the nature of this graph here. A marginal utility curve is always going to look like this. So we have units consumed per meal or unit of time, whatever it is, on the horizontal axis. You got total utility on the vertical axis. And what you see, it continues to increase to a maximum, but at a decreasing rate. So in this case here, from 0 to 5.5 tacos in a meal, you're getting more and more satisfaction, but the second taco is not as good as the first, the third is not as good as the second, and so forth. Hope that makes sense, okay? So total satisfaction is increasing, marginal satisfaction or utilities decreasing. So don't confuse those two, okay? You know, again, it's kind of like throwing a ball up in the air. You throw a ball up in the air, when it leaves your hand, it's going higher. It's doing two things. The height is increasing, but at the same time the height is increasing, what else is changing? What do you think, class? It's speed, okay? Is it getting faster or is it slowing down? When it leaves your hand, it's slowing down. So it may leave your hand at 30 miles an hour, but after, say, a second, it's only going 20 miles an hour. So that's kind of the relationship between these two things here. This is like position, and this is like speed or velocity. In other contexts, we'll talk about, in a basic calculus course, you'll talk about the rate of change of a function. So the second one is a rate of change of the first one. They use the term derivative for this. So if you've heard that word before, this is the derivative of this curve up here with respect to quantity consumed. So you'll notice something here. This curve reaches a maximum, then it begins to decrease. So we certainly don't want to consume more than 5.5 tacos. If you do more than that, you're wasting your money at that point, okay? You could spend on something else. But the other thing to note is that this rate of change function here becomes zero. The marginal utility becomes zero. There's a relationship we need to rivet on here. This curve becomes zero at the level of consumption corresponding to the maximum total utility. Marginal utility is zero when total utility is maximal. I would write that down or note that, okay? Marginal utility is 0 at the quantity where total utility is a maximal. That's just something that's very important, and we use that a lot in economics, in macroeconomics. We'll talk about, I mean, there's utilities for producers also. We'll talk about profit and so forth. A lot of times you'll have a function. You want to find out what level gives you maximum profit. Well, then a lot of times it's easier to look at this thing here, the marginal profit or whatever it is, look at where it's 0. So, but for us right now, for consumption, total satisfaction is maximized when marginal utility is 0. So we're going to study here in this chapter about consumer behavior and some axioms of consumer behavior. For one thing, I mean, not to get very detailed in this, okay? But first thing is, your book talks about that we're going to assume humans are rational, okay? There's a reason why we do things, and we do things presumably to make our situation better off. Okay, so human behavior based on comparison of marginal cost and marginal benefits is rational behavior. It's behavior designed to maximize total utility. In other words, you got a purpose in what you consume. There's a purpose. The purpose is to maximize total utility. Okay, that would be rational behavior. Total utility. Now, when I say total here, what I mean by this, the typical situation will be the utility you derive from consuming several different goods. I mean, tacos, that's not the only thing you eat, right? You eat pancakes too. Maybe that's all you live. But you eat a steak, you eat all kinds of things. We're going to look at the question, say, on your budget here in a minute, how do you determine what consumption bundle is going to give you the maximum total utility? And that's the way we typically think, okay? So that's called rational behavior. When you're invited to a dinner and you load your plate up, you're going through the buffet and you're loading your plate up with something, you may really like mashed potatoes, but very few people will say, that's all I want is mashed potatoes. Just pile it on mashed potatoes. I love potatoes so much. No, you want something to go with it. So we're going to look at how, we construct our consumption bundle in a way that delivers us maximum total behavior. And that's based upon rational behavior. That's what rational behavior is. There's a purpose in what we consume. So we must have preferences, right? Preferences mean that as a consumer, I prefer a pound of apples to a pound of oranges. Or I prefer tacos to Jell-O, or whatever it is. At any point in time, if you present to me two different goods to consume, I can tell you which one of those I prefer. So we have preferences. We're also going to assume that the typical consumer has a budget constraint. Okay, so you have only a finite amount of income that you can use to purchase goods and services in a period of time, say in that meal or what have you. And then we're going to assume there are fixed prices in this chapter. Prices that don't change. So a pound of hamburger costs so much, a gallon of gasoline is so much, and so forth. So these are some things we're going to assume as we explore consumer behavior. Okay, so that's going to lead us to this rule here that we will be using called the utility maximizing rule. Sometimes you'll hear this called the rational spending rule. And there's other terms for it, but this is the term in your text. It's a rule that a rational consumer is going to utilize to maximize their utility, total satisfaction. And so at that point, the consumer is said to be in equilibrium. We're going to see here in a minute. So if for you, let's just make this real simple. Okay, apples and oranges, again, you like 2 pounds of apples for every pound of oranges. Okay, it could be then that's what you want from your paycheck. It could be, actually it's going to depend on prices here in a minute. But once you get that right combination that you can purchase from your paycheck, then you are at equilibrium. You do not, you do not have an inclination to move off of this particular consumption bundle that delivers maximum satisfaction. So the consumer is going to allocate their income so that the last dollar spent on each product yields the same amount of extra marginal utility. Okay? For the last dollar you spend, so if you have $100 in income to spend for a week, you're going to spend that money, if you're rational, in a way so that the last dollar you spend would yield the same amount of extra marginal utility. Okay? So you want that $1, the last one you spend, okay? You want it to provide across all the goods, you want it to provide the same amount of utility. So at that point you want to have consumed enough of each good so that that would be true. In other words, I guess an easier way or more transparent way for us is to say that you get the same bang per buck for the last buck you spend. Okay? Now we have heard that a lot, right? Same bang per buck. What do I mean by that? I mean that the marginal utility of product A would equal over the price of A. This would be like bang per buck. The utility you'd get on that last dollar if you spend it on product A, that's the bang for that buck, divided by the price of A will equal the marginal utility of B over the price of B. Just say bang per buck here. That's really what this is. Sometimes we'll call this the bang per buck principle here. Okay? So, you might get apples maybe twice as expensive as bagels. Maybe twice as expensive. You'll satisfy this if you get twice as much satisfaction from the last unit of apples than you would from the last unit of bagels, because the satisfaction per dollar would be the same across these two goods. So in other words, if the price of A is twice the price of B, this will be satisfied if the numerator on the left is twice the numerator on the right. Okay, so you'd have the same ratio on both sides. So you see how if the numerator on the left, if the fraction on the left is the same as the fraction on the right, you get the same bang per buck. Could be it takes twice as many bucks to get an A as a B, but you'll have the same bang per buck if you get twice as much satisfaction from the last unit of A than you would from spending that dollar on a unit of B. All right, I hope that makes sense. Your book gives you this example here. We're going to work one here in just a second. This is apples and oranges. I made one up last night. I wasn't very creative, obviously, because I did another one with apples and oranges. But this is, it doesn't really matter, but this is on page 139 of your text, I guess. So you'll see here that apples are priced at $1, okay? Oranges at $2. And so you have here a couple things to note. These are total, oh, they didn't put the total utility on here. I forgot about that. They have marginal utilities here. So we could calculate these from total utilities, and we will here in a minute with the next example. But they give us the marginal utility associated with successive units of apples and oranges. So oranges cost twice as much as apples, but the marginal utilities are different here for the two units, for successive units of the good, each good. And you'll notice one else. Notice these numbers go down, okay? So the second apple provides fewer utils than the first apple, and so forth. And same is true for oranges. So this is real world. Why? What are we witnessing here? The law of diminishing marginal utility. Okay, so these numbers aren't going to go up. They're going to go down. Now, total utility would go up. So let me ask you this. For apples, it says the marginal utility of the first apple is 10, the second one is 8, and the third one is 7. What's the total utility this consumer would derive from eating 3 apples in this period of time? What do you think, class? Can you tell what the total utility would be from 3 apples? Marginal utility of the first is 10, of the second is 8, and of the third is 7. So the total utility over the first 3 apples is, can you tell? Well, you just add them up. 10 plus 8 plus 7. Got to be 25, right? So if you ate 2 apples, you'd have 18 units of whee, okay? But 3 apples is going to give you 25 units of whee, whoopee. So your total satisfaction will increase from 18 to 25 when you consume the 3rd apple. The marginal utility of the 3rd is 7. Okay, but the total utility from 3, the first 3, is 25. So if that makes sense, okay? So they could have given us total utilities over here, and we could have derived these. And we'll look at one of these in a minute. Same thing here, okay? So remember this rule we're looking at here. The question is, how many apples and oranges are we going to consume? Well, that's an important question, right? So certainly if you got a finite income, you go to Walmart, you're going to have to answer this question here. What's amazing about the human brain is, going back to this equation, it solves this for us in a way. The human brain is an amazing computer. It's always seeking, when you go shopping, it's seeking a solution, the amount of A and B that's going to solve the rational spending or utility maximizing rule. Like I say, the brain is an amazing thing. If you think about it a second, if you wanted to program a computer to drive your car, I mean, we have self-driving cars now and so forth, but imagine how much code it takes to program your car to switch lanes moving traffic. So we do this intuitively now, right? I mean, if I want to get over in this lane, the traffic's moving faster, I look in my rearview mirror, I see a gap in the traffic back here on my right side, and I see that gap coming up. I can anticipate that. I might be able to speed up a little bit so I can slide over. I mean, it's some pretty complex mathematics here. I mean, if you had to write the code to do that, we just do it. Same thing here. Same thing here. So, how many apples and oranges would you consume on an income of $10? Well, if you could ignore the solution here, they tell us what it is. But you're always trying to solve this thing here. In particular, you'll arrive at the solution if you always, at any point in time, consume the good that gives you the most bang per buck. Which gives you the most bang per buck. So you start on the first line here, okay? You look at the 10 over here, and you look at the 12 over here. And what is the 10 and the 12? That's the marginal utility divided by the price. So you go to the marginal utility and divide by the price. So the price of apples is 1, so the first 2 columns are the same, but the price of oranges is 2. So these numbers are a half of these numbers. So you go to this marginal utility per price, and you start comparing those. So first thing is the first thing you'd buy is an orange, because an orange gives you 12 utils per dollar. What is that? 24 utils. That's the marginal utility divided by price. So it's like you're using the right side of that equation right there. You get a higher bang per buck with the first orange than you do with the first apple. Now it may say, well, yeah, but this is when you start consuming over a whole bunch of goods. I mean, how many goods are in Walmart after all? Thousands and thousands. You're consuming over many goods. You're intuitively, at some level at least, you're doing this thing. You're asking yourself, which gives you the most bang per buck? So you buy an orange first. Well, when you buy an orange, that costs $2. So now you have $8 to spend, right? So now you compare the bang per buck on the first apple with the second orange. That makes sense? Each of those provide 10 marginal utilities per dollar. That's what these things will be right here. So you spend $2 for an apple, and then you say, well, I guess I'm indifferent between these two, so you might spend $1 for, did I say an apple? I meant an orange. You spend $2 for an orange, and then that leaves you $8 left, so you're going to buy that first apple and the second orange. They both give you the same bang per buck. So at that point, how much money have you spent? Okay, you've bought 2 oranges, you bought 1 apple. Sounds like $5, right? Okay, because you had $10 spent, you got 5 left. So you continue to spend in this fashion. So at this point, we have 2 oranges and we have 1 apple. So you say, I got $5 left to spend. Well, you're going to buy that third orange then, because it has more bang per buck than does the second apple. Does that make sense? So you'll buy another orange, those $2, that leaves you with $3. You'll buy an apple, which is $1, so that leaves you with $2. Oh, then you'll buy a fourth orange, and then you've exhausted your income, or your budget, that is. Okay, you have a budget constraint here. So we're going to say, now if you had $1 million, well, heck, you just keep buying these, but we're going to assume there's a finite budget here. So you see what we've done is we have maximized the total utility by always pursuing that good that gives us the greatest marginal utility per dollar, okay? So the way you get the highest marginal utility per dollar is by taking the marginal utility and dividing by the price. All right, so if one good is twice as expensive as the other, then you're going to reach here notice this is called consumer equilibrium here. Notice this. This thing is satisfied. The marginal utility per price on A is the same as the marginal utility of product B divided by the price of B. In other words, you're getting the same bang per buck, which is 8 over here on apples, as you do on oranges. This is the best you can do on $10. You might say, oh, why don't I just buy, why don't I just buy oranges, 5 oranges? You're not going to be as well off. Your total utility will not be as high. You're at what's called consumer equilibrium when you satisfy this bang per buck condition, where bang per buck is the same across all units. Okay? I got one here. Okay, I just made this for us today. Going to do something a little different. Let me pass this out and we'll work this together, okay? We'll shift our learning styles just a little bit here today. So I guess I should have been more creative. Apples and oranges, I borrowed that again. Okay, can I give you, Sarah, give you 3 more and you pass these over. And 2 here. Okay, because you're going to have, I'll guarantee you, you will have one of these, more than one of these on the next exam, okay? So we're going to go ahead and get ready for that Unit 2 exam by working this problem here. All right, so the question is, how many apples and oranges would you buy, okay, on this thing right here? Okay, so we'll go to the .chem. So you got a budget of $24 and price, again, I should have used, I think we see it doesn't matter what it is. Could be fish and pork or whatever. But the budget's $24. We may tweak this in a little bit. Price of apples is $2 and the price of oranges is $4 per pound, okay? So the question will be here, well, how many apples and oranges would you consume on a fixed budget of $24 a week? Now, this to me is a little more real world problem because we're not starting out with marginal utilities, we're starting out with total utilities, okay? So here's what you would do, okay? So first off is you need to determine, so I want to insert a couple of columns here. This first one here is the marginal utility. So this will be the marginal utility of apples. So we're talking apples over here. I want to make a column here, marginal utility of oranges, okay, MUO. Okay, so we're just going to go through and compute the marginal utilities of these things here. So, I don't have the number 0 here, so the idea is going from 0 to 1, the marginal utility is 20. All right, what do you think the marginal utility of the second unit, a pound of apples would be, whatever the unit is? What's going to go here? 18, right? Remember, marginal utility is the change in total utility over the change in quantity. Okay, so the change in quantity is just 1. Now, if this said 20,000, if this said 10,000 and 20,000, then delta Q would be 1,000, and we would have to take the total utility and divide by 1,000. Okay, but at any rate, we're incrementing just by 1 here. So the next one here, I guess, is 14. Okay, go 52 minus 38, or you got to add 14 to 38 to get 52. So it's always what I add to this number to get the next number. Okay, hope that makes sense. So this will be an 8, and this will be a 1, right? Because you would have to do that. Let's go over here and do the same thing. The marginal utility on the first is 36. The next one, you got to add 32 to 36 to get 68. 68 plus what? 26 will get you 94. And this one I can do in my head. Well, I thought I could. That's 20, isn't it? So 94 plus 20 is 114. And then this is 12. This plus 12 is this. And this plus 2 is that. So I got my marginal utility columns, okay? And then I'm going to look at bang per buck. So marginal utility divided by the price. So the marginal utility of A divided by the price of A. Okay? And then over here, I'm going to compute marginal utility of oranges over the price of oranges. So the price of apples is 2. I should have used, I just made this up last night. I sat at the dining room table and said, hey, we need to practice this. But I think you see the idea. And in fact, you're going to have one in the homework where there's several goods. There's like 4 goods, okay? The same approach, okay? Just wanted to work through this. But here, you'll divide each of these by 2 because the price is $2. So this is 10, 9, 7, 5, 4, and 0.5. So these numbers need to be decreasing. So I made sure I came up with numbers where those were decreasing because this is diminishing. I'm sorry, these numbers here need to be decreasing because, and that'll make these decrease as well. But these got to be decreasing because of diminishing marginal utility. Over here, I'm going to divide these by 4. Okay, so this is 9, 8, 6.5. 20 divided by 4 is 5, 3, and 0.5. Okay, I hope that makes sense. All right, so we got $24 to spend. We got successive units of both goods, and this is what they deliver in the way of bang per buck, marginal utility per price. So you say, okay, you start spending your money in a systematic way. So the first dollars that you spend are going to be spent on what? If you're smart, what are you going to buy first, apples or oranges? What do you think, class? You compare these two right here, okay? So you get more bang per buck out of the first unit of apples than you do out of the first unit of oranges. So you're going to consume this one. All right, let's see here. Let's got another sheet of paper, and we'll just keep track of our budget here. We'll just do that here. Hope that makes sense here. Ooh, hope we can see. So, I mean, where are we now? Kind of to this. Whoops. Kind of to the side here. Well, we had $24 to start with, and you bought a pound of apples, and those are $2 each. So I'll subtract 2. That leaves me with $22 left to spend. Hope that makes sense. Okay, so now you got $22. I circled this because we're going to buy the first unit of apples. Now what I got to do is since I've done this one here, I've done this one, I'm going to compare the bang per buck on the first pound of oranges with the bang per buck on the second pound of apples. So what am I going to buy next? It doesn't really matter, right? Okay, I'm going to buy one of each. So I'm going to buy this one, and I'm going to buy this one. Make sense? Now again, this is pretty straightforward, but in the homework you got one with like 4 different goods. So this is always searching for the one that gives you the greatest bang per buck. So we're going to buy a pound of apples, the second pound of apples, and the first pound of oranges. That's $2 and $4. Okay, so I'm going to subtract $6, or 2 and 4. I could have done these successively. That leaves me with $16. Okay, so I'm just keeping track here of what's left in my wallet. What's in your wallet, right? Well, $16 is what's left. All right, class, what are you going to buy next? If you're just peeling those, say you didn't know how much money's in your wallet, and you're going to buy, you would buy the oranges next, right? Because it delivers the highest bang per buck. So you're going to do that. Okay. So, I mean, we've taken care of these here. So you're going to buy you're going to buy this unit of orange because it delivers 8 utils per dollar. So oranges are $4 each, so you subtract 4, leaves you with $12, okay? There you go. So now you got $12 left. What are you going to buy next, class? Apples or oranges? Apples. All right, apples. There's $2 for apples. Okay. So you take 2 off of 20, off of 12. Leaves you 10. So, I mean, we bought that 3rd unit of apples. Then you're going to buy oranges, right? So you're going to circle this because you're comparing 6.5 with 5. So you're going to buy oranges, and they're $4 each. So I'll come back here 4. See what I'm doing? So that leaves me with 6. I got $6 left. So with $6, I choose between apples and oranges. So no, they're the same, aren't they? In fact, with $6, I can exactly buy 1 more unit of apples, 1 more unit of oranges. Okay? It just turned out this one. It doesn't always work out this way. But I subtract 6 here, and I've exhausted my budget. I have consumed 4 units of apples, 4 pounds of apples, and 4 pounds of oranges. Okay? Now, like I say, when you do this one in your homework, which you'll have one, I've noticed here, let me go to it, you're going to have. Now, they helped us out here, but because, again, they started in your book with the marginal utilities. You should be able to find marginal utilities from total utilities, just as we did here. It's a little more realistic, actually, but at any rate, I think it is. That may be debatable. But you should be able to get from total utility to these columns here, marginal utility. Notice here we have 1, 2, 3, 4, 5. 5 goods. They each have their own price. They'll tell you in problem 4, they'll tell you some of these are priced at $18, some at $6, and so forth. So what you do is you take your budget. In that case, I think you have, forget how much you have, $128 or something. But you take your budget, $106, I see it here. Take your budget and you start spending that budget down systematically like we did here. You always, first few dollars, you spend it on the good that delivers the greatest bang per buck. It's the rational spending rule. You say, well, yeah, that makes sense, right? But there's a certain profoundness about the maximum spending rule that we want to appreciate here this morning. So what we see here is that, say in this case here, for this example here, this person, $24 a week. Okay, if the price of oranges is $4, they want to buy 4 oranges. Okay, four oranges. So and that's this example here. They give you one again in your book. Want to come back to the one in your book? It's equivalent to this one. Again, we'll see here on page 139. If the price of oranges is $2, price of oranges is $2. In this example, we wanted 4 oranges. So we're going to assume that for this consumer here, on their budget, $24, their demand curve is well defined. It has a certain position, and it's going to also have this point to it as well. This consumer here, for the example that's in your text, it's going to be true that at a price of $2 for oranges, so this is going to be the price of oranges, this consumer is going to want 4 units of oranges. So this point here, $2, $4, is on this consumer's demand curve. Does that make sense? It's on this consumer's demand curve. So for $4 or for $2, the quantity that they'll demand will be 4 units. So you have Q doing this here as well. Now we're going to add another point to this in a minute, and we're going to plot the consumer's demand curve. What we'll do here is basically you could rework this problem, but you need another point. To get a linear demand curve, you need another point. So what we're going to do here is we're just going to lower the price of oranges to $1. Now you would expect then a higher quantity of oranges to be consumed, okay? Because we're kind of used to that. So you could rework the same problem. You could do the same problem here. You could just change this value over here from 2 to 1. So I'm just going to write 1 there. I don't like to write in my book very well. But you could do that. Put a 1 here instead of a 2 and work through the same problem. You're going to go further down this column over here if this is a $1 instead of $2 in the denominator. Okay? Really, if you shrink the denominator, you increase the value of the fraction. You might try that, say tonight or something. Put a $1 here. Don't mess with the price of apples. That is the price of other goods. Don't mess with the income here, $10. So we have $10 of income here, or budget to spend. So you don't change the budget. You don't change the price of the other good. What we do, and the only thing we do is we change the price of the good we're looking at, oranges, from 2 to 1. And you're going to go further down the chart. In fact, you'll go all the way down to this line. Okay? Now these numbers will be different because the price will be different. But at any rate, you'll go all the way down to the 6th unit. It's a good example to try to do. It's not a big deal. And you'll get this unit right here as being on the demand curve. This is how we can trace out the individual consumer's demand curve. After all, the demand is the relationship between the price people are willing to pay and the quantity that they'll consume. They're always, for every point on this curve, they're satisfying the utility maximization rule. They're trying to get as much utility off of their consumption, off of their budget as they can. Notice what we're not doing. We're not changing income. Income is fixed. Okay, in fact, it's $10. Leave the income at $10. The price of other goods is also fixed. These things, the price of oranges, we're starting with kind of a simple example here. If you change the price of other goods, or if you change the income, you'll change the position of this curve as we've seen in the past. Remember, determinants of demand. If your income goes up and it's a normal good, you shift this thing to the right. If the price of other goods goes up, that'll affect the position of this curve as well, depending on whether apples are substitutes for oranges or complements with oranges. Okay? I kind of look at those two as supplements. I can eat substitutes, rather. That's what I mean, substitutes. So, you know, for my lunch, my wife's got me kind of pared down here for lunch, but I noticed I had a sack of fruit there. So it could either be apples or oranges. But I kind of look at them as substitutes for me. But steak and potatoes, those would be complements, right? You want a little of both in a meal. So again, these are things we talked about as being determinants of consumption. Okay, and when you start tweaking determinants, you'll shift this curve either left or right. Okay. But at any rate, the main thing we're looking at here again is that this rule, this rational spending rule, is a very handy thing, and we're using it, I call it rational spending rule, because a rational person would allocate their spending in this way. Okay. All right, so you have a way here of determining the demand curve. Okay, for today, we're going to explore it in a little more detail next time. We'll look at these two effects that we've alluded to before, substitution and income effects. But actually, when we lowered the price of a pound of oranges, two things happened. Two things happened when we did that on a fixed budget. The first thing is that when we lowered the price of oranges, oranges became relatively less expensive than our apples. Okay, they became cheaper than apples. Okay, so you have this substitution effect where you actually, on whatever your income is, you're going to substitute away from apples to oranges because the price of oranges got cheaper. The other thing is there's an income effect here. Your real income actually goes up when something you normally buy has a price that goes down. You can buy a bigger basket of stuff, okay? So those two things are going to work together here in this instance where we see price and quantity demanded move in opposite directions for almost every good. There are theoretically some goods where the law of demand does not apply, and not very many. But anyway, we'll come back to this in the appendix to this chapter. I would like for you to read the appendix to chapter 7 next time, if you would. Okay, so if we go back to the slides here, all right, we'll talk about, again, these things here, determinants of an individual's demand. These are things we've talked about, and we see them here in action. There's the preferences or taste that you have. Now, that's where the numbers in the chart come from in the first place. We're going to say how many utils you have for the second pound of apples. Okay, that's a reflection of taste and preferences. Or that you got more utility, marginal utility. Well, let's just leave it at the first. You got more utility from the first pound of apples than you did from the first pound of oranges. I forget, I think that was the case, but either way, that means that you have a preference. If you're going to have one unit of fruit, you have a preference for one over the other. Okay, you have a preference for apples over oranges. And that's going to change as you consume things, but we can always make that decision. Income is fixed, so maybe it's $10, whatever it is, $24, and then the prices of other goods. These are things that are going to determine the position, the slope, and so forth of the demand curve. So we see that. So here we trace out that demand that we just did. When we lowered the price of oranges, we went further down that column that was on the extreme right. You have actually more real income to spend. Okay, for one thing, you can buy just as many apples as before, but now you can buy more oranges. So your real income has gone up when the price of oranges went down. So that's one thing that explains why we went from 4 to 6 when the price of oranges went down. Okay, so you have these two effects that work together. I want you, at least for today, to conceptually, have an understanding, or at least the definition of these. And then we usually list the substitution first. I put it on the right. But the substitution effect is the impact, a price change, say, of oranges from $2 to $1 a pound. An impact of a price change has on a product's relative expensiveness. So, it makes sense that oranges become cheaper relative to the price to apples when the price went from 2 to 1. And then there's the income effect. The income effect means that you're changing your real income, what you can purchase on your income, the goods, what you can put in your shopping cart. That's your real income. So the impact of a price change on your real income is called the income effect. Now, for normal goods, the income effect is, I'm going to say, negative in the sense that if the price goes down, your real income goes up. Okay? The substitution effect's the same thing. If prices of oranges went up, they're cheaper, so you buy more. Substitution effect. But also, your real income goes up, so you buy more oranges because your real income goes up. So in that case, when the price of oranges went down, you buy more oranges for these two reasons here. So there's this negative relationship. The substitution effect will always be negative. It's a negative or inverse relationship. If you want to use the word inverse, there's always an inverse relationship here for the substitution effect. When the price goes up, you can say, when the price of a good goes up, you demand fewer units because of the substitution effect, because the good is relatively more expensive. However, the income effect may work in the opposite direction. In fact, it will for normal good, for income inferior goods. It'll work in the opposite direction. So let me just put it this way. Okay? In fact, I could write a chart here in a minute. But these two effects work together for normal goods. They work oppositely for income inferior goods. Okay, all right, thank you. So if the price of oranges goes up, okay, you buy fewer oranges because of the substitution effect. However, if oranges is an inferior good, then you might buy more oranges due to the income effect because your real income went down. Now, oranges is kind of hard to conceive of. We all like oranges, right? What if it's ramen noodles? Okay, use that a lot. So the price of ramen noodles goes up. You're going to buy fewer ramen noodles because of the substitution effect. Because ramen noodles are more expensive relative to other things you'd buy. But relative to your real income, that's a different thing, okay? If the price of ramen noodles goes up, your real income goes down. Okay? Ramen noodles is an inferior good. So if your income goes down, you want more of it. Okay? Let me go to the dot cam. We'll write it this way because I said a lot of words there, okay? Let's write it this way. Again, Radar, can we go to the document camera here? Okay, so you have two types of goods. You have normal and you have inferior. Sometimes we say income normal and income inferior goods. Sometimes we'll just use those words. All right, so we're going to look at the price of a good. Say A for apples or oranges, doesn't matter what it is. Okay, with that you have a substitution effect and you have an income effect. Okay, so suppose for a normal good for a moment. I hope I left enough room here. Maybe I'll tell you what. These two go together and these two go together. Okay. So if the price of A goes up, okay, and it's a normal good, the substitution effect says that the quantity you want to purchase goes down. And the income is going to go down. These move together for normal goods. So price of A goes up, is relatively more expensive with respect to oranges or whatever, and your real income went down. Normal means you want less of this. Price of A goes down, you want more because of the substitution effect, and you want more because of the income effect. You see how for normal goods, you know, you always have this inverse relationship here. Okay, so you could talk about net over here. The net effect is down. The net effect is up. Now, how about for inferior goods? Price of inferior goods could go up or down. Substitution effect is the same thing, okay? It doesn't matter whether it's normal or inferior. The good's relatively more expensive if the price goes up. You hold everything else constant, ceteris paribus. So this arrow goes down and this arrow goes up. Income effect, okay, income effect. Well, if it's an inferior good and the price goes up, your real income goes down, and you want more of that. I want to draw a short arrow like that. I made it short on purpose, okay? Okay. And in this case here, the arrow went down, so that means your real income goes up, but it's an inferior good, so you want less of it, so I'm going to draw a downward slope. Now, I drew this on purpose. Actually, theoretically, this arrow can have the same length as this, but it hardly ever happens. I mean, it doesn't happen. I mean, it's something I can draw on paper, but we don't know of any goods that are like this. What I'm saying is, this arrow will point up for this good. This arrow will point down for this good. I drew these small because that's always the way it is. But theoretically, I could have drawn a big arrow. Theoretically, but we have never observed a good where this arrow is as big as this arrow for an inferior good. Okay? There's a name for that. They're called Giffen goods. Giffen. Okay. But I'll just say that on net here, you know, you would expect then this to exceed this. So this should go down maybe a little bit, and this should go up maybe a little bit on net. All right, here's the thing though. These are always opposite, because if A goes up, you know, it's relatively more expensive. Price of A goes down, is relatively cheaper. These things right here, okay, go in opposite directions for normal goods. They go in the same direction for inferior goods. Okay, I hope that makes sense, okay? Hope that, it's kind of a Rosetta Stone. Remember seeing the Rosetta Stone in the British Museum, British Library Museum. I think it's in the British Museum. There it is, you know, it was used to crack the code. It was used to decipher hieroglyphics. So it's got 3 different scripts on it. Same thing here. You file this away, it might be kind of handy for you here. All right, enough of that. Okay, your book talks about some applications and extensions. This is kind of interesting, some discussion on page 143 of your text. Let me just say here, let's thumb to page 143. They talk about when the iPads came out. When the iPads came out, you know, they had a lot of utility that was not noted before, because the consumption of digital data was enhanced by iPads, but not necessarily the processing or the ability to create digital content and edit documents, which we could already do on desktop and laptop computers. That iPad is really a handy thing. So your book talks about, at the bottom, page 142 and 143 top, there, why the iPad was such a hot item to start with, okay? This marginal utility per price was a very, very large number, okay? But they do talk about the diamond water paradox here, okay? We're going to get to the diamond water paradox, which is something, if we don't have time in the next 2 minutes to get into, I want you to read about next time, because it's going to hinge on looking at this relationship just a second. What if I had 2 goods? Marginal utility of A and marginal utility of B could be determined, and of course the price are observable. And I had not an equality, but I have an inequality. One is greater than the other. Now, we were actually using this a while ago. When one ratio was higher than the other, it governed our consumption, okay? What if this were true here? Here's the question: would we consume more or less of, say, A? If the marginal utility, say, if you didn't satisfy the rational spending rule this week, you went back and you looked and said, you know what, I didn't get the last bang per buck on that last dollar. This is for apples and this is for oranges. Okay, so next week I'm going to buy what? More apples or fewer apples? What do you think, class? If this is less than this, would I buy more apples or fewer apples? Now, again, the assumption is the prices are static. They're not going to change. But if on a fixed budget, say that was $10 a week in the book, right? I reallocate my spending so that I can get equality here. Then I got to buy more one good and less of the other. Okay? So the question here is, would we consume more or less of A? Of course, if I consume more of A, I'll consume less of B at the same time. Does that make sense? So, what do you think, class? More? Okay. Anybody want to say less? Okay, so I want to drive this fraction up and this one down. Let's think about that a second. Can't change the denominators. Price of apples and oranges are fixed. So I'll drive this up. So the only way I can drive this up is I need to drive marginal utility of A up. How do I do that? Consume more A or less A? Remember the law of diminishing marginal utility. So as you consume more, marginal utility goes down. So if I consume less, the last one has a higher marginal utility than the last one did in the previous period. So I consume less of A. Does that make sense? If I consume less A, I'll drive up that numerator on the left side of that inequality. We'll work more with that next time, okay? Okay, we just have to peel off here now. Read the diamond water paradox. That's